Welcome back to the course on data science by RouteFabric, and today let us look at the data lifecycle. The data science lifecycle can be split into 7 parts: the business understanding, data mining, data cleaning, data exploration, feature engineering, predictive modeling, and data visualization. What is business understanding? The data scientists in the room are the people who keep asking why. Why are we doing this? What is this important? Why do we need to do it? And they are the people who want to ensure that every decision made in the company is supported by concrete data and is guaranteed with a high probability to achieve results. When you're getting to understand a business, you're going to ask these 5 general questions to decide on which machine learning model you want to use. How much or how many consists of a regression model? Which category usually defines is it a classification problem? Which group usually refers to a clustering problem? Is it weird usually decides if it's an anomaly detection like credit card fraud and stuff like that? And which option should be taken is a recommendation of the project. Keeping these 5 questions in our mind, we'll be going through this course. Next up, we have data mining. Data mining is the process where after you define the objective of your project, which is the business understanding, and you understood what the problem really means, it is time to gather useful, insightful data representing your problem. If the data is given to you, you basically won a lottery ticket and you can be happy. If the data needs to be created, it will be a long, gruesome time because you need to create the data without bias. That means the data needs to be as random as possible. Next up, we have one of the most important and time-consuming steps in data science, which is data cleaning or data pre-processing. Data cleaning means better prediction accuracy. If your data is not clean, you will get flawed accuracy or flawed information. For instance, the data could also have inconsistency within the same column, meaning that the same row could be labeled as zeros or ones, and the others could be labeled no and yes, which technically mean the same thing for a human, but the computer will understand this as 4 different variables. Next up, we have data exploration. Once the data is fully clean and you have the project idea in mind, you can do the data exploration stage, which is basically brainstorming of data analysis. This is where you understand the patterns, the bias in your data, and you can see the trend of the data. Using all this information, you're ready to form your hypothesis about your data and the problem you're tackling. Feature engineering is also a crucial step similar to data pre-processing. In machine learning, a feature is a measurable property or attribute of phenomena being observed. If you were to predict the scores of a student, a possible feature is the amount of sleep they get. The 2 main steps that take place in feature engineering are feature selection and feature construction. Feature selection is a process of removal of features which might create noise in your model. This is also done to remove the curse of dimensionality. Feature construction is a process where you create a new feature based on different features. For example, you can add 2 features together to make a new feature. This could be something like, is there a chance to rain? Do you have an umbrella? And you can combine both these features to have a new feature known as, is it raining and do you have an umbrella? Rain with no umbrella. Now, let us look at what curse of dimensionality means, which is tackled by feature selection. The curse of dimensionality refers to the phenomena that occurs when classifying, organizing, and analyzing high-dimensional data that does not occur in low-dimensional spaces, specifically the issue of data sparsity and closeness of data. To overcome the issue of the curse of dimensionality, dimensionality reduction is used, otherwise known as feature selection, to reduce the feature spaces with consideration by a set of principal features. After your data is cleaned and pre-processed and you have done your feature engineering on your data is ready for predictive modeling. Predictive modeling is where machine learning starts. After data pre-processing and data engineering, we can use the data to predict. While making our prediction models, we usually split our data into two groups, training data and testing data. The usual percentage of how you split it is 80 to 20 or 70 to 30% data. The training data is used to train the model using machine learning algorithms, which we will be also covering in this data science course by RouteFabric. The testing data is used for the checking or predicting the data and seeing how accurate our data is for the testing data. Lastly, we have data visualization. Data visualization can be thought of as a really simple task because all you're doing is taking the data and you're visualizing it on a graph. But actually, it is a really tricky field because data science combines a lot of fields: psychology, statistics, art, biology, computer, IT, hardware. Everyone wants to use their data. Every different field wants to use their data to see what it actually means. With an ultimate goal of data visualization is that we communicate the data in a simple yet effective and visually pleasing way. Once you have derived the intended insights from your model, you have to represent them in a way that different key stakeholders in the project can understand. I hope that was informative. To learn more about data science, please visit routefabric.com. Thank you and have a nice day.